Hey guys, sorry we missed class this morning, but we are going to go over 511 and 512, and I think I put 510 and 11 in my email, but it's 511 and 512. Alright, so next week before Thanksgiving break, just a couple things. We'll make up our test help next Friday at 8:30. We'll have quiz help for 509 Tuesday at 9:30, 512 Tuesday at 10, and 513 Tuesday at 2:30. Quiz help for 514 Thursday at 9:30, and then 515 Thursday at 10. So we're going to talk about circumcenter and incenter of the triangle, and when I email you this, I'm going to email you a graphic organizer to go with these lessons. So here's just some vocabulary. I'm not going to read them to you that we're going to go through. This is your graphic organizer, so if you've opened the email, make sure you open that up. We're going to go over circumcenter and incenter. So first, let's look at circumcenter. So you can see here, when you move these angles, when it's an obtuse triangle, the circumcenter is outside. Sometimes it can be in the middle. Let's see if we can make these all. See how it stays the same, but it can go outside of the triangle. You can play with this. This is at mathisfun.com, triangle centers, and you'll have I'll make sure you have the link. So what does that show us? The center, called the circumcenter, can be both inside or outside of the triangle. The center is where all three special lines cross, lines that are at right angles to the midpoint of each side. So each of these lines are perpendicular bisectors. So they bisect the triangle, this side of the triangle, in half at a right angle, perpendicular bisectors. So an acute triangle is inside the triangle. A right triangle is on the side of the triangle, and we'll talk about that when we do our examples. And then an obtuse is outside the triangle. And you can also find all this at mathisfun.com. Talks about the circumcenter. And there's the circumcenter theorem. And it tells us that since any line point that lies on the perpendicular bisector is equal distance from the endpoints of that line. So that means that these segments created are all congruent. And also, since these are perpendicular bisectors, it means that this segment is congruent to this one is congruent to this one, and this one is congruent to this one. Alright, the end center, the other center we're going to talk about, is the end circle. It means it's where these angle bisectors, they split each vertex into two equal angles. And we can play with that one a little bit. Let's see. So there's end center. So see, no matter where we change it, it stays inside the circle. And it always has this circle. So that means the center, where this point meets, is always going to be the same distance when this makes a right angle. Can make it do that. I don't think that one could be a right angle. So that would be they're the same distance. there because it's all the radius of this circle. So they're always the same distance when you take from the center to the side of the triangle. And we'll talk more about that. So circle fits inside of the triangle is called an inscribed circle. The largest circle that will fit just touches each side of the triangle is called the incenter, and it's where each angle bisector meets. So each of these angles are bisected into two equal parts, and where those lines meet is the incenter. So they are always inside the triangle, and you can learn more about the incenter at Math is Fun. Let's try some problems. So this first one is, what is the coordinates of the circumcenter? Well, the circumcenter is where each side is bisected by perpendicular bisector, so making a right angle. So it means bisector means two equal parts. Well, these that are lined horizontally along the x, parallel with the x-axis, they're easy to see where the middle of this is, because there you go. Well, I want this right properly. Sorry. There we go. So you can count 1, 2, 3, 4, 5, 6. So right here is where the perpendicular bisector, and the graph allows us to put in a perpendicular line that just goes along the graph, and I'll make that a little thicker so you can see it. Alright, so that's our first, and you only need to make two where we can find the oops. Sorry about that. And now we are going to count the other side. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be at 4, and make a straight line again. So right here. And you can also use the distance formula or the midpoint formula and find the midpoint. And if they weren't, it wasn't a right triangle, then you can use your slope formula to find a perpendicular line that's at the midpoint. But this one makes it easy because it's a right triangle. So we can see that our circumcenter intersects right here. Remember, when we have a right triangle, it lies on the hypotenuse like this, and it is at 2, -1. And this goes through that explanation. Now we have just the coordinates. So you can see that this is also a right triangle because you can tell that this has the same x values here. So they are lying parallel to the x, and then these have the same y values. So that means they are lying parallel to the y-axis. So you can see that this is a right triangle. So what we have to do is, where it lies along the x, where our x values are the same, find the distance between the y values. And that's going to give us our y coordinate. So, well, the midpoint of that. So there's the distance between there will be 12 because they're both 6 away from the x-axis. And so the midpoint would be at 0. So if we're thinking about this, so we have our axis. So we know this is somewhere way out here at 23, and it's at 6 and negative 6. And so we know that's 12. So the midpoint would be right on the line. So that's the midpoint there. And then our ones that share a y coordinate, 6 and 6, we can see the distance between them. X is 5 and 23. So you subtract 5 from 23, which gives you 18. Half of 18 is 9. So it would start at 5, and 5 plus 9 equals 14. So that means our circumcenter is going to be at 14, 0. Our two midpoints. Here we have perpendicular bisectors, and we know that DG is 2, and CA, which is this whole thing, is 9.6. So we know that this divides it in two equal parts. So we divide 9.6 by 2, and we know that these congruent segments are 4.8 each. And we are looking for DB. And see, all of these are congruent to each other. So we just have to find one of them, and we can find the rest of them, because that's the circumcenter theorem. And so we plug this into the Pythagorean theorem. A squared plus b squared equals c squared. And next slide shows this all worked out. So you find the half, plug it in the Pythagorean's theorem, and find that it's 5.2. All right. Which is construction will locate the end center? Remember, the end center is made up of the angle bisectors. So you have to construct an angle bisector of each vertex. All right. Since P is the end center of HJK, we're going to find the measure of DHP, which is this one right here. That's what we're looking for. So this is a right triangle. We know that all triangles add up to 180 degrees. So we can take 80 and subtract 90, because all right triangles have a right angle. So that leaves us with 90. I know our other angle is 70, so we subtract 70, leaving us with 20. And this is an angle bisector, so this one also has to be 20. And now, our end center makes that circle where all of the that touch at a right angle are the radius. So since this is 4.5, AP also has to be 4.5. There's the explanation of that one. All right, this and next one, we are looking for the area of this triangle. I'm going to highlight it. This triangle here. Okay. And so first we know that these are congruent, and we know the sides of these. So we plug this into Pythagorean's theorem. And we find that this is 24. And they're congruent. So this one is 24. And this is 36. So to find, you do one